What's up everybody, Aditya Mahajan here and welcome back to yet another LeetCode video. So today's problem is an easy level problem number 905, also called as sort array by parity. Now the question is saying that we are given an integer array nums and we need to move all integers to the beginning of the array and followed by all the odd integers. Now and we need to return an array that satisfies this condition. Now the input is, for example, 3 1 1 2 3 4 in following order, and we need to return an array such that starting numbers are odd, even, and remaining numbers are odd. So it does not care about what the ordering of the elements is. So first half should contain all the even, second half should contain all the odd, and if we have just zero, we just return zero. Now a simple solution would be, the first thing that comes to the mind is, okay, let us create a new array, and in first iteration let's get all the even numbers first, and then we push all the odd numbers in the second pass. So the first solution is pretty simple. So what we are doing is we are just creating an answer vector, and in the first iteration we are checking if the current element is even. If it is even, we are pushing it to answers, and in the second loop, we are checking if the current element is odd. If it is odd, then we are just pushing those and we are returning answer. So there is no big brain behind this. It is just simple two pass solution. Okay. So a bit better approach is, what if we just combine those two? Can we do it in a single pass? So actually, as if you take a look into the outputs that they have given, the ordering does not matter. So what we can basically do is we can start doing the operation from the both ends. Okay. So let's say we have two pointer, and when we start from both the ends, whenever we see an even, we'll put it at the front, and whenever see an odd, we'll put it at the end. Okay, so that is the solution for the second approach, and the code is something like this. So what we are doing is we are creating a same answer vector and initializing it with the size of the earlier nums vector, because the size does not change. Now what we are doing is we are taking two counters or two variables, start and end. Start with 0 and end with the last index, and we are iterating through the complete nums array. Now what we are doing is, if we encounter any number is even, then what we are doing is we are updating the start. So start index is answer of start. We are just updating the start index value, and we are putting it to the number that we have, and we are incrementing the start pointer. And if we get a number which is odd, we'll put it at the last. So that is what we are doing. And once we exit out of this complete for loop, we will have one pass solution with extra space. Okay, so this is the second approach. Now here in the both the approaches, the time is O of n. Second one we are doing two pass, first one we are doing one pass. But can we just remove the space complexity? So to remove the space complexity, what we can do is this is the very similar to the previous problem that we saw. So this video is a part of arrays playlist. So if you haven't watched it, check the link in the description. So what we can do is we can just keep a bound sort of checking, and before that bound we can keep all the even variables, even numbers, and after that particular bound we'll keep on putting the odd numbers. Okay, so to understand the solution, let's look at the code directly. It would be a lot easier. So what we are doing is we are keeping a bound sort of thing, or an edge, before which there would only be even numbers, and after that we'll keep the odd numbers. Okay, so we'll start that index would start at 0, and whenever we encounter an even number, we will just keep on putting the even number behind and put the odd numbers in front of it. So that is what we are doing. We are iterating through the complete array vector, and in that array then we are checking if that particular element of the array is even. If it is even, in that case we are just swapping that element with the element on the corner, which is an odd. Okay, and once we do that, we are just incrementing the even boundary, that is the boundary at which we need to swap. Okay, so that is the third approach. Now this is no space, O of 1 space, and O of n time complexity, because we are just iterating once through the complete this. Now there is actually a one more solution which can come up. So this is a sort of QuickSort approach. So the textbook solution that we had, and they have the editorial actually has a very great explanation to it. So if you haven't checked it, you can check it here, and I'll be using the same thing to explain it. So for this, what you need to think of is, let's say at every point, if we do with two pointer approach, what we can do is every number, if we check it, to be even or odd, then it needs to be either on the first or at the end. Okay, so let's say we have 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30 31 32 33 34 35 36 37 38 39 40 41 42 43 44 45 46 47 48 49 50 51 52 53 54 55 56 57 58 59 60 61 62 63 64 65 66 67 68 69 70 71 72 73 74 75 76 77 78 79 80 81 82 83 84 85 86 87 88 89 90 91 92 93 94 95 96 97 98 99 100 101 102 103 104 105 106 107 108 109 110 111 112 113 114 115 116 117 118 119 120 121 122 123 124 125 126 127 128 129 130 131 132 133 134 135 136 137 138 139 140 141 142 143 144 145 146 147 148 149 1 Okay, so the way that we check is with the parity, that is like doing a modulo operator in short. Okay, so for any two numbers, what basically happening is we are checking if it's a mod 2 is 0 or a mod 2 is 1. If it is 0, we are putting it into the even, we need to put it at the start, whereas if it is odd, we need to put it at the end. Okay, so for if we do a two pointer approach, then for I and j, two different pointers, we have four cases for this set sort of thing. Okay, so either it can be four possibilities, that is either this is even or odd and this is even or odd. Okay, so here we are saying that I is from the start and j is we are taking from the end. Okay, so in the same approach, then what we have is we are having four cases, and let's consider what the four cases are. So if we start with having first is even and second is odd, so everything is correct, we do not need to do anything, we can just move ahead from reduce the array size which we are looking at. Now let's say the parity comes up to be, or the modulo operator comes up to be 1 and 0. In this case it is wrong, and what we need to do is we need to replace them. Okay, so if we replace them, the even number would come at the start and odd number would go at the end. Okay, so that is the second scenario. Third is both are what we say even. In that case, only the starting element is correct because we need even element from the start. So we just increment that from the start so that we are there at the correct position, but we need odd at the start so that we can swap them again. Okay, similarly, if both are odd, then only the last element which is present is at the correct place and we increment from there. Okay, so the solution comes something like this. Now, if what we are basically doing is we are taking two pointers I and j, very similar to the previous approach, and we are iterating while both of them meet, or they are like I is less than j. Now, once that is the case, we are taking the modulo of both the numbers, that is nums of I and nums of j, and if nums of I is great, so this is the exact case. Like if this is 1, the first element is the smaller index value is 1, and the greater index after parity taking modulo is 0, that means we need to swap them. Okay, so that means we are at the even and odd and we need to swap, and after that they would get at the proper place. Like starting we have even and at the end we have odd. So that is what we are doing. Otherwise, in the all the other cases, we just are incrementing I if first number is even, and if the second number is odd, we are just decrementing j. Okay, so and once we are at the end of this, so what happens after this is until we reach opposite ends, we enter this loop, this condition inside the loop, and we are just swapping them. So at the end, when we are both are towards the center, we will have a complete array having starting even and at the end odd elements. So yeah, that's the solution. After we end up after end of this loop, we just have the our answer and we just return that. So that's the fourth approach. So yeah, I hope you understood all the four. If you did not understand, comment below. And yeah, that's all. If you need more such LeetCode content, subscribe to the channel and I'll see you in the next one.